This is January 2015, paper 2, and this is question number 4. The student investigates the stretching of rubber bands. She stretches 4 rubber bands as shown in the photograph. She applies a force of 5 newtons and measures the length of the rubber bands. She repeats the experiment with different numbers of rubber bands using a force of 5 newtons each time. So, 5 newtons with 1 rubber band managed to go 43.2. With 6 rubber bands, it only went 17. So for the same amount of force, you're getting less stretch. So estimate the length of the rubber bands shown in the photograph and use the value to complete the table. So for 4, what we would do is we would log on to here, measure it down. You would of course use a ruler, and they're looking for 18.7 centimeters. Don't have to put centimeters because it's at the top. And they're going to give you 0.5 plus or minus either way of that number. So you can be 0.5 centimeters below that or 0.5 centimeters above. So it suggests 2 reasons why the estimate may not be accurate. So there's lots and lots of reasons here. Parallax error. Depending on where you look at the thing that you're taking the measurement from, that could change it. So say if I was looking, I wanted to know the level of water. I've got a meter ruler here. My water level is there. If I look with my eye here and look down, I'll measure it as being too low. But if I look here and my eye is too low, I'll measure as being too high. I need to be exactly in line where I'm taking that measurement in order to get the precise value. So, an accurate value, I should say. There could be also some zero error. So does this start at 0? So it's a bad ruler because you might not be able to see this. Better on the close-up. It doesn't start at 0. The end of the ruler is worn off. So it's not a good way to measure it because we're not sure if we're actually starting at 0 centimeters there. Notice that the hook is curved as well. So do we measure from this point or do we measure from this point of the curve? It's got 2 different values. The hook is stretching the bands differently. So this band on the outside is more stretched than a band in the middle because of the curve of that hook. And the bands are not close to the ruler. Why wouldn't we put the ruler maybe underneath them instead? That would have been better. And then we could look down and get a proper value. So when they ask you questions like this, suggest 2 reasons. Just think about ways in which you would take that measurement to be really, really, really accurate. Are they doing exactly the same thing? Is the way that they're doing it the best way to do it? Okay, so now we're going to suggest how the student made this a fair test. So if they ever use that word fair test, then you're just going to say control variables. Did they keep everything the same throughout the experiment? If they didn't, then it's not a fair test. It's not going to be repeatable because they kept letting things change, which they weren't meant to. And that could be, the control variable here is they use 5 newtons. 5 newtons each time. If they did that each time, then it is a fair test. The number of rubber bands is a series of whole numbers. Suggest this type of variable. If that type of variable, state the name of this type of variable, it is a discrete or a discontinuous variable. Display the results of the student's investigation on the grid. It should look something like this. Mine is terrible because I can't use a ruler on my computer, but of course you should. Now the clue here was state the name of this type of variable. It was discrete or discontinuous. So the results that you should have plotted would have been a bar chart. Because with 1, you get 40. With 2, you get this. So that's the results of the investigation as a bar chart. And there's 4 marks for putting things like the axes are labeled with units. There's a suitable scale, so you make sure it fills up at least half the grid. And all 5 bars all 6 bars here are plotted for the correct data. If they're not, then they're going to take away 1 mark for each mistake that you make in the plotting. And then the next and final question is describe the relationship between the number of rubber bands and the stretch length. It is inversely proportional. Now that means as one goes up, the other goes down, and it should do a nice curve like that, which is inversely proportional, or you could say it's non-linear. They're looking for 2 marks here, so there's a negative correlation. You could talk about the pattern. You could say it's a curved line. You could say something about as one goes up, the other goes down. Anything like that would be appropriate. That's question number 4.